once again, we have another secant squared. But notice the setup, how there is the x cubed term, but there's also an x squared term, so that we know the relationship with power rule with a derivative is that the function given and the derivative always are one off in its exponent term. So here's 3 and here's 2, which is one off. So that gives us a hint as to what to choose u to be. So u should always be the term with the higher exponent term. So u equals x cubed, which means du equals 3x squared dx, which means dx equals 1 over 3x squared du. So here we see this 3x squared term in the denominator, which will cancel the x squared term out once we substitute. So let's go ahead and do some substitution. X squared, secant squared of u, and 1 over 3x squared du. And if we simplify this a little bit, the x squared terms cancel out, and we're left with a 1/3 secant squared u du. And this looks very much like our previous problem, except the u here is a different substitution. So carrying out this derivative, we know that it's tangent of u plus c. And finally, replacing our u with x cubed plus c. So there's our answer to this massively confusing looking integral. So once again, when trig functions pop up for integrals, just refer back to your properties table. And keep in mind why we select u and why we substitute u for what we substitute it with. Keep in mind the power rule. So always go back to the basics of your rules, and the chain rule will be quite straightforward. So thanks for watching Educator.com. We'll see you in the next lesson.